in memory of the birth centenary of our famous Indian mathematician, Srinivasa Ramanujan. Of course, his birthday was in the last month, December 22nd, but we have decided to celebrate it now when the students are present here. Before we begin the function, as a mark of respect, may I request our guest of honor and the speaker for the day, Professor C.K. Raju, to come and pay homage to the bust of Panditji, Pandit Madan. Thank you very much, sir. As we all know, the name Srinivasa Ramanujan is a very common name in the households of our country. But still, as a matter of formality, because we are celebrating his birthday today, let me share a few thoughts about his personality. Born on November 22nd in a very remote village of Tamil Nadu called Erode, he had spent a very brief amount of time on this earth, because in the span of 32 years, we had lost him when he was as young as 32. So, among his major achievements, he was the first Indian to be elected in the Trinity Academy, and people, the hagiographers of Ramanujan and the historians have also credited that if it was not for Hardy, the world would have not known Ramanujan. So, Hardy was needed to recognize the intelligence of Ramanujan. Among his other achievements, what he is known for, there are lots and lots of mathematical constants, theorems named after him, like Ramanujan conjecture, Ramanujan prime, Ramanujan theta function, so on and so forth. He was a very deeply religious Hindu, and a very oft quoted quotation that is ascribed to him is that an equation for me has no meaning unless it expresses a thought of God. So, without much ado, I would stop here in talking about the life of Ramanujan. Incidentally, this month of January also happens to be the birthday of another mathematician of our country by name, same name S. Ramanujan, who was an assistant professor, later an associate professor in TIFR Bombay, and birthday of another famous Indian scientist, Y. Subbarao. The other Srinivasa Ramanujan, I will not spend much time about his life and biography, but very interestingly, in the history of our educational paradigm, I think he will be counted as one of the few who protested on why he was promoted from assistant to associate professor. When he was promoted, he launched a protest saying that he did not deserve the promotion, and he wanted the promotion to be abrogated. And later what happened, I am not clearly aware. But the other scientist whose birthday also falls in the month of January is not much well known, even though the Indian government has released a postal stamp in his honor, is Y. Subbarao. He is one who is credited with the discovery of antibiotic called tetracycline. And he has worked across his major contributions has been in combating cancer. Perhaps down the year, we may organize another lecture in commemorating his memory, because his contributions towards the combating cancer has not been well recognized in the academia as well as in the media. Now, with these few words, may I now come to the subject proper of the day, that is the talk the talk by Professor C.K. Raju. So, although the name is not unfamiliar to the academic circles, but the formality demands that I formally introduce him. Professor Raju, born on March 7, 1954 in Gwalior, Madhya Pradesh. And I'm not sure in a contemporary era whether the word polymath can suit anybody. But we are indeed fortunate that we have a person here to whom this word polymath can be truly ascribed to. For he is not just a computer scientist, he is a mathematician, an educator, a physicist, a philosopher of science, historian of science, a flautist, etc. I'll not put the full stop there, because these are the aspects which I know about him. There may be more which he may have to shed light to us. He He's with the Center of Studies in Civilization currently at New Delhi. In the 80s, he was the faculty member at the Department of Statistics, University of Pune. He was a key contributor to the first Indian supercomputer, Param. He has championed the research in claiming that the infinitesimal calculus was transmitted to Europe from India. He has authored 12 books and many articles on subjects like physics, maths, history of science, philosophy of science, etc. True to his scientific training, he does not mince words in calling out the flaws. For instance, pointing out Einstein's flaw and showing that Einstein's work had, quote unquote, remarkably similar to that of Poincaré. One of the very few brains that have spent significant effort in the study of time and its measurement. For instance, he has disproved that the very commonly read and still continue to be taught in the school textbook, physics textbooks, that the time period of a simple pendulum is independent of its amplitude. I'm sure even today if you go to any 7th or 8th class textbook, this is what is taught, that the time period is independent of the amplitude, and he has actually thoroughly disproved it through his pendulum experiment. So many such bold accomplishments are galore to his credit, and for that reason, why even people like Paul Dirac have the following to say about him. Quote, Mr. Raju has shown that he has great initiative and has worked extremely hard, unquote. Karl Popper, one of the famous philosophers of science, has the following to say about him. Quote, I found your critical remarks very good, unquote. With these few words, may I now request Professor C.K. Raju to come to the dais and address the gathering. Thank you very much.
Well, thank you very much for inviting me, especially Dr. Ramnath. And I'm very happy to be here. As I was just now discussing with your director, you might have heard of C.P. Snow and his story of two cultures. So you have people in the sciences and you have people in the humanities, and they don't talk to each other. And that is the sort of thing that has been happening here. So let me try to explain what I think I have a lot of material, so I should not spend too much time on preliminary. I have. चलिए ठीक है, you can hear me? All of you can hear me? Okay. So, basic question, what is it that I'm asking? We keep hearing a lot about our Ganit. We did this, we did that, and so on. But the unfortunate fact is, सब लाइट बंद करने की जरूरत नहीं. We teach what I would like to call Western ethno-mathematics. चेहरे तो देखें ना. So this is the problem, and we teach it because we believe it is superior to what we did. So we should be clear, either we are proud of it or we are not proud of it. Let's examine what's the case. Let's examine it as best as possible, because I am asking this question, is it superior? Is it actually superior what we do? And I am going to argue that it is inferior. By the way, I was also in the math department in many places, but anyway, I'll leave that aside. That's Wikipedia, that's faulty history. So what is superior, formal math or Ganit? That's what is the central question. And think of it as a what-if scenario. What if Ganit were superior? Just consider the possibility that something Deshi is not inferior. And as a simple example, I want to give the case of the Gregorian calendar. So, that's a religious calendar named after Pope Gregory. And our secular festivals are defined on it. We adopted it after independence. And it does many things. Alienates us from our culture because our festivals don't come on the same day of the calendar. They come on different days. Christian festivals come on fixed days. It is inferior. All months are all sorts of random lengths. Something 28 days, 29 days, 30 days, 31 days. Thoroughly unscientific inferior calendar. Even after the Gregorian reform. Damages our core economic interest. The core economic interest is in monsoon and agriculture. That's what the economy still depends on. And there is a video on that, Tale of Two Calendars. So maybe you could take look at it for more details. That's the link, but you can just Google, you'll get it. And it encourages superstitions. Whenever you give a date, you have to say AD BC. What is this AD BC? Year of our Lord, before our Savior. Those are just superstitions which the church has designed this to encourage them. So please take a look. It's an ADBC superstition which you get after along with your ABCD. And so blindly imitating the West may harm our interests, harms our economic interests, harms cultural interests, and so on. And our scientific interests. Those who talk of scientific temper never raise this issue. Why do you have to take the name of Jesus did not exist, Jesus is a myth? Why do you have to say year of our Lord and so on for every date? But that's because colonial higher education came as church education. All your universities which you think so highly of, Oxford University, Paris, and so on, they were church institutions, set up by the church, managed by the church for centuries, totally under the control of the church. Alright, this fact is never told to you. You are told, get higher ranking, imitate them. Better you imitate, the better you are. Why should you imitate them? You should think of your interest, as simple as that. What benefits your interest, not what benefits them. So colonial education, when it came, it made mission schools very important for admission to the university, for a job. Because all of you take up education for a job, right? Am I wrong? Okay. So in the process, you indoctrinate children into stock propaganda. West is superior, non-West is inferior, imitate them. That was the stock church propaganda all along, down the centuries. And that's what you get today. And the aim is to capture the mind of the colonized to make them believe they are inferior. This is not true only of India. It's true all across the world. It's true in all the Muslim countries. You have 51 members of OIC. It is true across Africa. Everywhere they went and told them. And of course they killed all the Red Indians and Maya and Inca. They are not left to tell them that they are inferior. They just killed. Or the Australian aborigines. Mass genocide. But anyway, the colonized believe. That's what I was brought up to believe. Deshi means inferior. Right? And the imported thing is superior, whatever it is. So whatever is imported from the West is superior. We have that firm belief, ingrained from childhood. But we never examined it. We did not examine it in the case of mathematics. We did not examine it even in the case of calendar. So obvious. But we took an inferior product just because it's West. So what is unthinkable for the colonized mind may be true that Desi might be superior in some cases. It's unthinkable, but it may be true. That's what I'm saying. And the calendar is the simplest example. Ganit versus math is a little more complex. Okay, so let's look at what we want to do. We want to expunge the propaganda in our education system. How? I don't say reject everything and accept everything indigenous. Be critical. Have you been critical? Have you ever examined the issue critically? Where has it been examined? Show me. Why do we then teach formal mathematics? We had never examined it. So we did not examine it even for 71 years after independence. And the Deputy Education Minister, I asked him, why don't we do so? He said, it's not in my power. I think higher ups can do it. It's not. Power is outside the country. The fact. It's almost impossible for university professors to do such a comparison because their entire career depends on how well they imitate the West. The norms of university ranking are defined like that, to make you a slave, to keep you a slave. Because something is knowledge only if you publish it. It is quality knowledge only if you publish it in the West. Otherwise, it's not knowledge. When I first went to IIT Delhi, people used to publish hundreds of papers, centuries. It's like, I don't know, Virat Kohli and whosoever else. They're racing for a record. And they would publish, of course, that time in international and national journals. So they would publish in Thailand, in Vietnam, and so on. So now they made it clear that is not international. What is international is only US, Britain, and so on. So there is not a single Western journal where you can publish such a critique. You cannot define it as knowledge. That's how we have been tied up. So anyway, they use the system of pre-censorship and they will reject it if you submit it to them. Right? That's the situation. What you want to think of, you cannot think of it. That's the meaning of hegemony, of complete hegemony. Mind is controlled. Okay, so we are enslaved by the system. So the agenda that I want to outline today is Swaraj in Thought, which is the basic agenda that you need to have a second battle for freedom. The first one was not sufficient. And this does not require any Western approval, so it is critical to do that comparison now. Okay. So again I repeat, because most Westernized people are unable to understand, we are not talking of blind acceptance of anything. We are talking about critical understanding. And this has been repeated in Malaysia. There was a huge debate many years ago when we talked of decolonization there, because it came there first. And this is the clear point that has been made. Be critical and choose what is best, but first be critical. First examine both the things. Okay. So let's check whether Western ethno-math is superior. The indoctrination starts in the class 9th NCERT text. What does it say? It says all indigenous non-Western math everywhere, Egypt, Babylon, wherever is inferior. Western math is superior. Remember the propaganda. West is superior, everybody else is inferior. And that's repeated there. What the Greeks did was superior. That's what it says. Alright? So we teach students to imitate Western ethno-math, saying it is superior. That's all. There's no comparison. It is superior. Why is it superior? So it says, class 9 NCERT text, chapter 5 on Euclid's geometry, available online. We find that in some civilizations like Babylonia, geometry remained a very practical oriented discipline, as was the case in India. If you are practical, you are inferior. Why are you becoming engineers? You are going to do only impractical things? So this is what is stated in our textbook, that it was inferior because it was practical. Nobody objects. So once more, okay, Egyptians built the pyramid, did something. Practical, only practical. They did not develop it as a systematic science. What's a systematic science? In civilizations like Greece, the emphasis was on reasoning behind why certain constructions work. That's the argument given. The Greeks were interested in establishing the truth of statements using deductive reasoning. So this claim that Greeks did some special kind of math needs to be copied is copied from racist historians like Rausball. That's the same thing. The history of mathematics cannot with certainty be traced back to any school or period before Greece. So all early races, note the word races, knew something about numeration. Yet the rules they discovered were neither deduced from nor did they form part of any science. Whatever else they did was something inferior. What the Greeks did was something superior. It was part of the West. That's what you should do. And Euclid did geometry, so you should imitate that. That's the claim. You should do what apparently Euclid did. All right. So this justification that is offered is false in 5 different ways at least. If you search harder, you will find at least 100. I'll talk only of the 5 different ways in which it is totally false. Okay, so let's look at what these 5 lies are. First lie is there is no Euclid. What's the source for Greek geometry? Euclid. That's the major source. Euclid's element. Said to be the major source. But there wasn't any Euclid. Could the book be written by him? There is no evidence for Euclid. Plenty of counter evidence. And I have offered a price of rupees 2 lakhs for the slightest evidence about Euclid. Anybody wants can claim it. Price has been standing for the last 10 years. I offered it in front of the Malaysian Deputy Education Minister. I repeated it. So this was accepted by the leading authority in the West, David Fowler. Maybe I can just long back, 2002. I don't know whether this will work, so I can try. Not going to work. That's the link. You can copy and paste it. Maybe if there is time. So basically what happened was that there they complained, somebody in the list complained, somebody called Peter Flor. Who is this C.K. Raju? He says Euclid, much is attributed to Euclid without evidence. Will some historian tell us what is known about Euclid at present? And what is known about the books he supposedly wrote? So David Fowler was the leading Western historian of Greek mathematics, replied, what is known about Euclid? Nothing. What is known about his books? The earliest comes from 888 CE, closer in time to us than to the supposed time of Euclid. So check it out, it is still there, the Historia Mathematica. But NCERT will not remove it, they just refuse. We don't have evidence, but you believe. There is no need for evidence. They go so far. The head of the mathematics department there, 10 years ago, 11 years ago, says, what is the need for evidence? We go by a committee. We teach blind belief in Western education. You have no right to ask for evidence. 2 lakh prize, you can't provide anything. You have no right to ask for it. You are offering it, that's a crime. Why are you asking for evidence? We go by a committee. Okay? So millions of students must therefore also believe it the same way. NCERT doesn't know. You don't know. Nobody knows. And you know there is counter evidence. But you are not to be believed because you are not a Westerner. We only teach blind belief in the West. That's the purpose of education system. That was the purpose of colonial education. That's still our purpose. So this is a cartoon for that. Why do you need evidence? We go by a committee. Committee believes, you have to believe. That's the education you are being taught, not given knowledge, indoctrination. 10 years it is standing. It's a scandal. Absolute scandal, nobody is perturbed. So Indians certainly use reason. Say, unique thing for Greeks to use reason? Nonsense. Every system of Indian philosophy except Lokayat accepts reason. Buddhism, Jainism, Naiyayikas, Advait Vedanta, so on, except for Lokayat. So it is completely false that others did not use reason. And we know it. After all, we know the systems of our philosophy. We know it is completely false. But the textbook says it. And they say, your knowledge, if you know it's not worth anything, you get a certificate from the West. You do not know your philosophy until somebody certifies it. So Anuman was the word for it. Pratyaksh Praman, Anuman, Upman, and you can reject Shabda Praman. No problem. Nobody uses Shabda Praman. So Aryabhat, let me give you an example from mathematics. He deduced that the earth is round. How did he deduce it? He didn't go to space. He said it's round like a kadam flower. But his disciples, Dalla and Vateshwar, explain. Far off trees cannot be seen. The explanation is in a chapter called Mithya Gyan Nirakaranam. All sorts of false knowledge prevails. They are removing it. So, why? Because far off trees cannot be seen. The horizon is round. You can actually deduce the radius of the earth from here. It's done in my book on Raju Ganesh. It was done in India. It was done very accurately. It was done more accurately than what Columbus did 500,000 years later. And better than Newton's first estimate. And the Bible said the earth is flat. They did not make the deduction. With all 4 corners of the earth, you can see there are 4 corners and so on. No point. So, People not only knew that the earth is round, they reduced its radius very accurately to within 1% of its true value. So that's a Kadam flower in case you don't know. But Aryabhat not only used reasoning or deduction, he also used facts, also used empirical proof. So, for example, in Ganit 13, he says horizontally. You've seen what a mystery does? Spread some water, then you know whether it is flat, drains off, not. Or use a plumb line to determine the vertical. It's also part. The empirical facts as well as deductive reasoning are part of it. So, what we did in Ganit is empirical fact plus reasoning. Okay? Let's be clear. And that is exactly what science does today. You don't have experiment, you don't have science. But now, you see what formal mathematics is. Well, we'll come to that. First point is Greeks did nothing different. A complete falsehood that they did something different. So look at it. Plato, of course, well, one thing they did, which the Egyptians did, that Plato connected mathematics to religious beliefs about the soul. The very word mathematics means mathesis. And Plato explains that mathesis is remembering the past lives of the soul. The famous dialogue, Meno, just check it, it's available online, Plato, Meno, search for the second occurrence of soul. It's all about religious belief. The word mathematics means arousing the soul, mathesis. Make it remember its past life. Similar notion of soul to what we have in Hinduism. Alright? All learning is recollection, stated by Socrates and Meno. And people are interested in more details, I'll get into more details tomorrow. But it's a false myth that Greeks gave some special kind of proofs. Completely false. This is the nature of church propaganda. They don't tell one lie, they tell hundreds of lies. So you keep thinking that is true, this must be true, that is true, and you are taken in. So, where do we get those proofs? Look at the actual manuscript of the element. What do you find in the actual manuscript? Proposition 1. Proposition 1 gives an empirical proof. Okay, what is it? To construct a triangle, equilateral triangle on a given base. So, what do? You take the base, and then you must have known how to create a compass. You measure this, draw one arc like that, keep it there, draw another arc like that, and then join this base. Okay? This was called the fish figure, by the way, in India. It has religious significance for, it's not accidentally the first proposition. So the fish figure was, it makes a cross in a simple way. And also the word for fish in ichthys, in Greek, has a special significance. It's an acrostic. Won't go into that. You can look at my book. So you make this fish figure. And then you join it and you get a cross. But point is, the issue is, those two arcs, see them as intersect. How do you know they intersect? Where is the formal proof? Where is the postulate from which you have deduced it intersect? Did not come into existence until Dedekind. And even after Dedekind just said something. He could not establish it. You needed Cantor set theory, and Cantor set theory was nonsense. So you needed formal set theory. So until the 20th century, there was no formal proof of this. Maybe you look at Hilbert synthetic geometry, you get something, but the point is, this is an empirical proof. You are seeing the arcs intersecting, they may or may not intersect. It's a pratyaksh praman, not anuman, not pure deduction. Okay, they just mislead you that Greeks did some pure deduction, completely false. Show me the proof, I'll give another 2 lakhs for it. Everybody knows this for 100 years, only our school text teaching false things. It's not based on any postulate which tells you that. For example, if the arcs are drawn on a pixelated computer screen, they are seen to intersect. They may not. Okay, they may have a common point. The pixelated screen, right? They may not have a common point. Okay. Likewise, there is proposition 4. Must have heard of it. The side angle side theorem in the original element. Two triangles have same side. Two sides the same and the included angle equal. The word is equal, not congruent. What you are taught is falsehood starting from Hilbert. The word is equal in the original manuscript. And that is how it was taught in Cambridge until the 19th century, end of the 19th century. I'll get you the Cambridge text. I have it with me if you want to see. It was proved empirically. How? You have these two. So you take this triangle. I better leave this. So you move this triangle from here, put this here, and put this side so that it meets this. All right? And then because this angle the same, this side will fall on that side, and so on. That's how you prove. Theorem 4, it's not a postulate. Today it is taught as a postulate. It was not a postulate in the original element. All right? So what is this? This is a empirical proof. You are moving it in space, putting it on top, may get deformed when you move it in space, like a shadow gets deformed. So this is precisely what was rejected by Hilbert and so on, and that led to the term congruence in synthetic geometry. But this is an empirical proof. The proof of the so-called Pythagorean theorem, which is the last proposition or the penultimate proposition in the elements, is based on this. That is why you make SAS a postulate. But it was proved there empirically. That is what the Greeks did. Our school text says Greeks did something special. They are complete falsehood. Okay. So it's essential. And so the proofs are just more prolix. 47 propositions you need, therefore they are inferior proofs. Because once you accept the empirical, you can prove it in one step. In the Yukti Bhasha, so this proof is given here. Just this paper is online. You don't need 46 intermediate propositions. Because you prove things empirically, you do it in one step. This is it. You have, it's about the, if you like, about the diagonal of a rectangle. But you can think of it in these terms. That you put the, they called it Bhuj and Koti, put the smaller square on top of the bigger square like this, and then you join these two, cut along this, and rotate this, you will get the some part of the figure, it's not visible, but there is a line here and a line here. So you rotate this, you will get that, get the square. You want the detailed proof, empirical proof, it is there in my book on Rajju Ganit. If you have such a proof, you don't need any of those intermediate 46 propositions, because the book was never about deductive proof, complete falsehood. It was about religious belief. It was a religious book. So I will go into that detail tomorrow. Point is, Greek proofs are no different. They just talked, that they told you it was deductive proof, and you did not bother to check. Not just somebody else's fault, it is your fault also. It's the fault of our mathematicians who never checked it. Supposed to check it, right? Never checked it. So actual Greek proofs are inferior because of this, but this is never revealed by the NCERT board. They only want to relay Western propaganda to schools. That's it. Now when you talk of Greeks, that's another lie. The Greeks did something different. What you are doing is you are hiding the church connection. Okay, what's the church connection? Solid fact is that the book was used as a church text for centuries. Why was it used as a church text? Find that out, understand it. And main point is, church burnt any theologically incorrect book, including the oldest Bibles which were from India in Aramaic. They were all gathered together. They were the Syrian Christians, gathered together and burnt in 1599 in what is called the Synod of Damper, Synod of Udayamperur, by the bishop from Goa. So, if they did not burn it, they used it as a text, it had to be theologically correct. You don't learn theology. Why should you learn about it? You learn it in this. So, it hides the church connection, that the church had some theological interest in the book. They never told about it. Greeks did something. Greeks didn't do anything. So, as I said, it was a Neoplatonic religious text. Neoplatonic means Sufi. The best, simplest description if you don't understand what is Neoplatonic. Abul Fazl al-Akbar biographer mentioned that it was part of his Talim. It was not translated because it was understood as a religious text. It had no practical value. You can prove all the 47 propositions in one stroke, in 2 lines. Why do you need all that? There's no practical value at all. So it was translated into Sanskrit by Samrat Jagannath as Rekha Ganit, commissioned by Savai Jai Singh into Jantar Mantar. And under growing Jesuit influence, well known that Savai Jai Singh was in touch with the Jesuit, misled him about the telescope and so on. About the telescope. So Euclid's Elements came into our school syllabus only with colonial education, replacing what was traditionally done as Rajju Ganit. No comparison, no this thing. Just change it. This is what they should be indoctrinated into believing it. And Cambridge University ritualistically required blind imitation of Euclid. Take a look at this book, it's available on the archive. You see the Cambridge syllabus. What they did, they changed it. Oh, you can provide your own proofs, but the order must still be followed. Okay, it's a foolish requirement. Absolutely foolish requirement from Cambridge made by their board. Why do you need to follow the order? Once you accept empirical proofs, you don't need the order. The order is if you believe there is a linear chain of deductive reasoning. If you are doing empirical proofs, you do it in one step. Order is absolutely irrelevant. So this kind of imitation was what was taught in Cambridge, very foolishly taught, and we think, oh, very great thing we imitated. Okay, so it has no value, but that is what Cambridge University did. And please download this and see how it changed the syllabus. This book by H.M. Taylor, Cambridge 1893. Pythagorean theorem can be proved in one step. Let's go to the fifth slide. There are lots of things to cover, so I'll just cover a brief summary. There is the church theology of reason. Why is the church interested? Theology of reason. Have you heard of it? So, what does reason mean, you should ask? Does it mean the church understanding of reason or some other imaginary understanding that you've got in mind? So, the Indians used reason. They used it differently. So, it was done because of the church theology of reason, little known to us, which was started during the Crusades. Why was it started? It was copied from Islam, from what is called Islamic rational theology. There was Christian rational theology. And what did they want to do? Because they were weak, militarily weak. Therefore, they wanted some kind of lie to use to supplement their lack of hard power. So they copied it, said reason is ours. Because the Muslims did not accept the Bible. How does a priest convert? They did not accept the Bible. They rejected it as corrupt. So they took it from Islamic Akli Kalam. And for the church, what was important was proof. Persuasion. They were not into calculation. They could not even calculate the dates of the calendar correctly. So what was important for the church was proof or persuasion, and that is why they said mathematics is about persuasion. Alright? But when you have a church interest in it, beware of doublespeak. So when our school text says reason, then it is doublespeak. Because you think it is normal reason. The way you use it in science, the way you use it everywhere, reason plus fact. Church reason, the special reason, metaphysical reason, which refer to, in church theology, reason minus fact. You are not allowed to use fact. And that makes you superior. How does it make you superior? Did you think about it? So we'll go into that. So anyway, they say to say that they use reason is a double speak for the statement we prohibit fact. Which of course the Greeks did not do, but the church did. And because they talk of Greeks, you never understand the connection. So Pratyaksh Praman is prohibited. Completely the opposite of loci. And this double speak is not explained because it deliberately misleads people to take it to mean something else. So it was politically important for the church because they had to use reason, then they could not accept facts. If we accept facts, all the dogma will be destroyed. So it was politically important, both the things were important. And therefore the church came up with this notion of mathematics. For example, Aquinas in his Summa Theologica, he talks about angels. How many angels can fit on a pin? More than one, he says. Why more than one? He makes a postulate. There is no proof about angels, but he proves that angels could fit on a pin, on the head of a pin. He postulates that angels don't occupy space. No facts needed. Just make a postulate. They don't occupy any space. So that's Aquinas dreaming about how many angels can fit on the top of a pin. That's the kind of context in which they wanted to use reasoning. What does God do? What was God doing before the world was created? Reason about it. There are no facts. And so they glorified, if you don't use facts, you are great. We'll see what they argue. So everyone accepts that empirical proofs are fallible. In India, the classic example is mistaking a rope for a snake or a snake for a rope. But on church superstition, deductive proofs are infallible. Deductive proofs are superior, they are infallible. Just think about it for 1 second, you will see what nonsense it is. Mathematics is superior to science. Because in science you use facts. So they said rejecting facts makes proof stronger. How does it make proof stronger? Why is it a superior method of proof? So point is, formal mathematics is based on that church belief that rejecting facts makes your proof stronger, and your object of mathematics is just to give proof without facts, based from starting from postulates, whether about angels or about anything else. Right. But actually formal math originated in the 20th century with Hilbert and Russell and so on. Why did it originate? Because the myth of Euclid collapsed. The myth that the elements has got deductive proofs, it collapsed. 100 years ago, in the West, we are still copying. So, my interim conclusion is, why do you need 5 different lies to make a point about the superiority of Western math? There is not even one truth in it. Complete falsehood. And if somebody tells falsehood, do you think he'll tell falsehood if the truth can be told? So, why do you need? Piling on is the sign of church propaganda, of course, but it suggests that the superiority of math cannot be established of formal math. Cannot be established truthfully. Therefore, you tell lies. You will not tell a lie when the truth will do. There is some motive for it, right? Motive is to fool people. So let's make the comparison now between formal math and Ganit. So what was the core question? Is it really true that formal math is superior to Ganit? As the church text says, with the help of, as our school text says, I'm sorry, it's not much of a difference. The slip, it's a Freudian slip. So as our school text says, it is superior. But is it really superior? So let's be clear what exactly is Ganit and what exactly is formal math. Alright? So Ganit, as I said, like systems of Indian philosophy, I give you an example of what Aryabhat did, accepts both fact and reasoning. Does not exclude reason. Standard Western caricature. See all those people who want to rebut me, oh, Raju is excluding reason. Of course not. He used reason. But he also used fact. Okay? So, except both these things. And it was practical calculation. What do you do in engineering? Practical calculation. You want to build a machine, you want to send a rocket to space, whatever you want to do, it's practical calculation. Nothing at all to do with metaphysics or proof or persuasion. Just practical calculation. And practical calculation always inexact. So it accepted inexactitude. Alright? It's irrelevant for practical applications if there is something slightly wrong. Natural state of affairs, there will be, in any measurement, there will be error. Or some inexactitude. I won't call it error. You call it error, you assume that there is something exact. I'm just saying it is inexact. Not assuming that something exact exists. Formal math prohibits facts and empirical proofs. Alright? It reasons solely from postulates, also called axioms. Today they are used interchangeably. So you are hypothesizing something, the angel can occupy this much space or not occupy this much space, no facts involved. And it believes, this belief is on religious grounds, that math is about proof, not about calculation. All practical value comes from calculation, nothing more practical value from proof or reasoning used to persuade others. And it believes that math is exact, formal math is exact. That's also superstition, I'll tell you why, what it relates to. Because it is eternal truth related to the eternal soul according to Plato, it is something which survives from there. So these beliefs are there that it must be exact, it's about proof, and it begins from postulates. So let me give you what Bertrand Russell's definition. Mathematics consists entirely of assertions to the effect that if such and such proposition is true, then such and such another proposition is true. All conditional statements. Okay? So we take any hypothesis that seems amusing and deduce its consequences. So if angels are amusing, deduce the consequences. Apparently. Supposedly the freedom we have. So formal mathematics may be defined as a subject in which we never know what we are talking about. Who knows what angels are? Whether they have 2 wings or 5 wings or 10 wings or what happens? But they have no wings at all. So we never know what we are talking about. And we never know whether what we are saying is true. And no, neither meaning nor truth. That's the definition of formal mathematics. You cannot have meaning unless you have some empirical component. So in a formal mathematical proof, every sentence is either a postulate or is derived from uh, two previous sentences by means of some rule of reasoning. There is no room for facts between postulate and theorem. And the postulates themselves, the first sentence, no empirical justification for it. So now I want to say, now that we are clear about the distinction, I want to say formal math is epistemically inferior. What is the advantage that is claimed? It is something superior kind of thing, systematic science, nonsense. It is epistemically inferior. You get no advantage from a formal mathematical proof. So let's start with postulate. So pure deductive proofs are actually inferior, according to me. Why? I mean, so it's formal math. Because formal mathematical theorem, what do mathematicians do? They prove a theorem. And what's the point of proving a theorem? It is at best a relative truth. A relative truth relative to the postulate. The postulates are false, the theorem is false. Theorem is not eternal truth. Alright? Yeah. Yeah. I'm giving you. I gave you one example in Aquinas, you were not paying attention. To prove that how many angels can. So is it a mathematical truth? Is it a physical truth? No, I'm saying Aquinas is one example, I'm giving you one more. So here is one example, Aquinas' conclusions about angels are false. They are correctly deduced, but they are false. There is no element of truth in them. Invalid knowledge, mythical knowledge, fantasy knowledge, Harry Potter knowledge. Another example, this was in my censored article, it's very simple. Okay. Example is all animals have two horns. That's my postulate. Don't ask whether it is empirically true. Empiricism does not enter anywhere, facts do not enter anywhere. A rabbit is an animal. How do they give this? All men are mortal. Socrates is a man, therefore Socrates is mortal. I'm giving a different form. Same logical thing, syllogism called modus ponens in Aristotelian logic. So therefore a rabbit has two horns. Has horns? Completely invalid nonsense. But it has begun from postulate, it has used modus ponens, it is logically deduced, it is a theorem. Give you Russell's definition, don't ask what the hypothesis, whether it's true or false. It is amusing. I find it very amusing that all animals have two horns. That's an amusing postulate. From that I have derived a mathematical theorem. I think if you understand mathematics, you understand this. So it's validly deduced, a formal mathematical theorem, and it is nonsense. Because the postulate is empirically false. There is nothing logically contradictory about it. I can have a world in which all animals have horns. I can imagine such a world. God could have created such a world, to use the theologian's language. Supposed to be necessary truth should be true in all worlds, right? In which the postulate is true. So the conclusion is false. Now the Lokayat in India rejected inference for this reason. They said it is inaccurate. It is not reliable. Unreliable knowledge. Deduction leads to unreliable knowledge. Alright? And why? Because they said that man went around at night, made artificial footprints, wanted to convince his girlfriend. So in the morning, people inquired, they looked at the footprints, they said there was a full wolf around. Everybody gathered in the city square, town square. They wrongly assumed that the footprints were made by a wolf. And the man was laughing, look at these fools, they are deduced that a wolf was around, but actually no wolf was around, I made this. They made a wrong assumption. We can easily make a wrong assumption. And this was the Lokayat argument. That is why they said deduction is not reliable, inference is not reliable, because you may start with the wrong postulates and therefore you may reach a conclusion which is not valid knowledge. So mathematical theorem is not valid knowledge until you have verified the postulate, which you can't do in mathematics. So if the postulates are unreliable, the theorem is nonsense. So let's consider a postulate of elementary geometry. The one and only one straight line between 2 points. Postulate made by Hilbert in his synthetic geometry. Foundation. Alright. Now try to empirically verify it with dots. Do you think it will turn out correct? Of course not. Always connect two dots with more than one line. False. Right? You have two dots, they have to have some finite size, connect this end to that, this end to that. Always do it. So the postulate is empirically false. Alright? Now let's see what the class 6 NCERT text says. Class 6 NCERT text says mathematical points are invisible. Invisible points. Because empirical world doesn't come into it, so what do you get? How do you verify this postulate about invisible points? I ask students, what do you know about invisible points? Do they sit in one place? Do they dance around? Do they do Kathakali or Bharatanatyam or whatever? How do you know? They don't know. Point is to talk about invisible points so that they are forced to rely on the authority of the text. There is no direct means of knowledge about what invisible points do, whether they are here or there or wherever. How do you know where they are? So here are these two chaps quarreling. I've shown the points, they are invisible. They're quarreling about the location of any invisible point. How do you settle the dispute? No way to do it. Because you cannot also infer where they are. On hardcore formalism. What does hardcore formalism say? So this is, as it would be explained, for example, this is explained in class 9 text of NCERT or in David Hilbert's book on Foundations of Grammar. So because you no longer have the empirical as a source, you get into a situation of infinite regress. The example given by the textbook is you cannot define by saying that a point is that which has no part. That was Euclid's axiom, so to say, in the book element, that was the axiom. You cannot do it that way because you have no reference, no empirical reference. So you have to define the word part and so on. Say something which has 0 dimension. First define a vector space, then define dimension, then say what? Or something which has 0 area. You have to first define area for which you need to define a point and so on. So it leads to an infinite regress. So not only you cannot see it, you cannot define it in other words. And you try to teach students this kind of nonsense in class 6 and class 9. So they are primitive undefined notions. You have to have that to avoid an infinite regress. But if they are primitive undefined notions, there is no way you can check them empirically. They don't exist in the real world. So you can say whatever you like about them. 2 lines pass through a point, 5 lines pass through a point, exactly 6 lines pass through a point, or whatever. So it cannot be empirically checked. Point I am making is postulate cannot be empirically checked or empirically verified. It is just what is amusing. Rabbits with horns are very amusing to me. So this is a general rule for all postulates of formal math. In general, they will involve a metaphysics of infinity. Talk of real numbers, metaphysics of infinity. Talk of set theory, metaphysics of infinity. And there is no way to verify metaphysics of infinity, which, by the way, happens to be connected to the church dogmas about eternity. I won't go into that, that's too complicated, maybe. So reliance on postulates ultimately means reliance on authority of the mathematician who laid it down. Somebody wrote the postulates for set theory, somebody wrote the postulates for real numbers, formal real numbers, and you believed in that. And you say belief in authority is better than belief in facts. I completely reject that. Okay, authority is 100 times more valuable than facts. It's just like saying Pope is infallible, believe whatever he says. Don't look at facts. Start looking at facts, you'll start wondering whether God exists or not, whether the soul exists or not, whether heaven and hell exist or not. Believe in the authority and everything is clear. But authority is more valuable than empirical facts, therefore formal math is inferior. Okay, let's look at errors of deduction. First thing was about postulates. We can go into this. Let's look at errors of deduction. So empirical proofs are fallible. Everybody agrees with it. As I said, the classical example is that you may mistake rope for a snake or a snake for a rope. Actually happened. But that's very easy to settle. Just tap the snake, it will just rise up, and then unfortunately the thing will be killed. Alright, that is what happened with that snake, which I saw. I will tell you that story another time. The point is, deduction too is infallible. Is fallible, I'm sorry. Deduction claimed to be infallible, but it is fallible. Why? Very simple. Just apply your common sense. You may mistake an invalid deductive proof for a valid one. There is a mistake in the proof. So many times it happens. What is difficult about it? So now what do you do? For centuries, for example, for centuries, all Western scholars, all their greatest people, their greatest thinkers kept saying that the Euclid is the classical example of deductive proof. infallible deductive proof. It was nonsense. All the proofs were invalid, considered as deductive proofs, because the empirical gets in. So they all made a mistake for centuries. Snake rope you can determine within a few minutes, few seconds. So they made a mistake, and these errors in deductive proof, unlike errors in observation, which are errors of the senses, these are errors of the mind. And these errors of the mind are more persistent than errors of the senses. So, more persistent and more frequent. So, let's say you have to make a complex deductive change in time, you have to do it in real time. Chess. Always you will make an error, 100%. You are very lucky if you get through it once in an entire game of chess without making an error, because the computer will always defeat you. Because you make an error, not just you, it will defeat the greatest grandmaster you have got. The human mind is more easy to deceive than human sense. So if you have to do this kind of complex deduction in real time, you will make an error. Almost invariably, I have said, which is all right, the human mind muffs. Okay, so there are mistakes. If mistakes are possible, how will you check it? I was doing my PhD, I had to make a calculation which was 110 pages long. And then I could have no idea because we didn't have any mechanical computer programs. So what to do? And nobody has done it before, so I am doing it. You cannot check it against anything else. Repeat it second time, repeat it third time. 110 page calculation, it would take a month. Very complex calculation. And then, so you are doing it inductively. The validity of a deductive proof can only be checked inductively, because it may be subject to errors. How is deduction superior to induction? At least it is as fallible as induction, because you are checking its validity inductively. And errors of the mind are more frequent, we have seen. So therefore again, deductive proofs are more fallible. Alright? Worst of the matter is, you cannot actually check. Just now that Michael Atiyah made a claim, he proved the Riemann hypothesis. How many of you can check it? Don't understand what all he has done. So what will you do? You have to rely on authority to tell you whether it is true, because it is beyond your capabilities. So even to decide whether something is valid or invalid, let's take a proof of a simple thing. 1 plus 1 equal to 2. Can anybody here check it? I'll just show you the proof. 378 pages. That is for integers. For real numbers, formal real numbers will run into at least 1,000 pages if you do it from first principles. How will you check it? So Russell's proof takes 378 pages, and you have to blindly trust, oh, he's got the Nobel Prize, so he must be right. That's the way you check it. That's blindly trusting authority. Blind trust in authority always leads to mistakes, leads to something more fallible than empirical. So this is Russell's proof. If you want to see, I can amplify it. Let us see if you even understand a single sentence. And if you don't know the proof of 1 plus 1 equal to 2, then what do you know? You understand one single sentence. Anybody here understands a single sentence? Tell me. This is 1 plus 1 equal to 2. Nothing more complicated than that. Forget about everything else. Must believe, nothing else. You are taught to believe, believe authority. That's the whole point of formal mathematics. See if you understand anything here. Completely in symbols, that's a formal mathematical proof. Not a single word of English should be there. I taught this to my son, and I still believed in formal mathematics. When he was in 9th standard, and he took a version of the chain rule to his school, and obviously nobody understood it. But the teachers decided he was a genius. So if you cannot check the proof of 1 plus 1 equal to 2, and you say deduction is infallible. So logic is not universal. Formal mathematics just superstitiously assumes that logic is two-valued. The church studied Aristotelian logic, so-called, Aristotle. No evidence that it's due to Aristotle. But they studied it. And Al-Ghazali made a casual concession that logic binds God, because he was talking about causality. So the church believed it. They did not understand. So this is here, it's that Aristotle invented the syllogism, it's false. you take a look at my article on non-Western logic, it's the Springer Encyclopedia of Non-Western Science. So Aristotle of Stagira, real historical figure, quite different from Aristotle of Toledo. It's just a fantasy based on late Arabic texts. They attributed. Did he need logic? This just killed people. They killed Socrates. No room for arguing. And they threatened to kill Aristotle. But then before that, before even that historical Aristotle, there are multiple systems of logic prevalent in India. Look at the Digha Nikaya, where the Buddha will say, "Arey, this chap is wriggling like the eel." He says he denies this, evam pimeno, tathati pimeno, anathati pimeno, and so on. I don't believe this, I don't believe the opposite, I don't believe so on. So he is wriggling like the eel. So there was two-valued logic also. Chatushkoti Buddhist logic, which is not multi-valued logic. It is quasi-truth functional logic. It is not even truth functional. Will you prove your mathematical theorems? So many mathematical theorems prove by contradiction, everything will fail. So theorems will change. If you change logic, it will change. If you change the postulate, and so on. But they superstitiously believe that logic bound their God. And if you want that, there is an article which is available online on the religious roots of mathematics. Al-Ghazali made that concession, and you can read about that concession in my book, 11 Pictures of That. So it was a concession that he made to Islamic rational theology and to the philosophers. But formal mathematical proofs use only two-valued logic. So it's not culturally unique, nor is it empirically certain. Quantum logic is quasi-truth function. You can take a look at my book, Time Towards the Consistent Theory, or if you are doing quantum computing, to understand that there is a different kind of logic. Schrödinger's cat can be both alive and dead in one instant of time, and the world will not collapse, it will not be trivialized, because from a contradiction you can deduce anything you like. A and not A implies B for any proposition B. It doesn't happen in the real world. So the logic of the real world is not necessarily two-valued, or not even multi-valued, not even truth functional. So they are culturally colored beliefs about logic, and they are, at best, what you can say about mathematical theorems are they are culturally colored, fallible, relative truths related to unverifiable postulates. Why do you want that? You want valid knowledge. When you're doing engineering, you don't want something with so many qualifications. You want to know something which is, if not exactly valid, at least approximately valid, so that you can do a task practically. You can make some machine, or you can make it do some task or whatever. So you're not interested in all these kinds of things, but the church was interested. It's not of any interest to engineers. Why should you learn it? So interim conclusion is that proofs only from some unverifiable, irrefutable in the sense of Popper, irrefutable, therefore metaphysics, where bhautik, no word for metaphysics in Indian languages, not parabhatu, where bhautik. That's not serious proof for mathematics. So the proofs of formal mathematics are epistemically inferior to universal empirical proof. They believe this is a chair, you can see it. You don't need to prove it to you in a very complex way. Simple sensory perception. You do not have exactly the same view of the chair as I have. Approximately the same will do for all our conversations and everything else. This is a philosophy called Shunyavad or zeroism. Approximate, because you keep changing. You're not the same people you were when you came. And you don't think that you have drastically changed, that somebody has died and somebody else has come. So Ganit is therefore epistemically superior. Alright? We have looked at epistemic superiority, let's look at practical superiority, or practical inferiority of epistemic. Why do you learn math? Practical value. Not interested in metaphysics. Are you? You're learning it for practical value as engineers. You apply it for practical value. The practical value of 1 plus 1 equal to 2 long pre-existed Russell's proof. The practical value in a grocer's shop is still the same. What did the proof add to that practical value? The 378 page proof. Did it add an iota to the practical value? Are you able to better do your thing in a grocer's shop? No. So it detracts from practical value because it makes simple things like 1 plus 1 equal to 2 so complex that theology loves that complexity. Then they can impose the thought. So this is my cartoon of Russell. Goes to a grocer's shop and he's bought a dozen things. He's trying to figure out what that dozen thing is by proving it. 378 pages for each edition. How long? The grocer is obviously annoyed. He's lost his patience. So, formal mathematics lacks any practical value, does not add any practical value. Normal mathematics of 1 plus 1 equals 2. So you say 1 orange and 1 orange makes 2 orange. If you want to send a rocket to the moon, ISRO and NASA will use a computer program. What will the computer program do? It will use floating point numbers. It will not use real numbers because real numbers are unreal. That's just double. You cannot write down even a single irrational real number. Exactly. In computers, in the real world. Therefore, they use floating point numbers. They don't even obey the associative law. They teach the law. They're criminals. But that's what they need for practice. According to formal math, they are not. So you are doing the numerical solution of differential equations. And all applications of national importance which I explored, I was head of the CDAC application development group. All these things, space, oil, and so on, they all do this. We tried to take the help of some of these people who do so-called applications of mathematics. What they can do is elliptic partial differential equation under this condition, under that condition, under this condition, the solution exists and is unique. I want to extract oil from somewhere. I'm not interested in the existence of uniqueness theorem. It doesn't tell me anything. So I could not find any mathematicians to employ for that practical job. So they teach them so badly, they are not able to do anything. Just don't know how to do a practical job. They can only do, theorem and this. Paid high salaries, could not get. So everything you do there in a practical context is normal math, is calculation, is inexact. So I think I covered that. No use of formal real numbers are made in any of the above applications. Now the point is that formal math makes math difficult. Many people have difficulties with it. And this is the cause. 1 plus 1 equals 2. You saw how difficult it is. So it makes math difficult to teach. Extremely difficult. Right? So we do not teach 1 plus. Therefore, you do not teach it using formal math. You rely on normal math when you want to teach 1 plus 1 equals 2. Now can you see the cartoon? Here is this girl and she is going to prove. Her teacher has asked us what is the solution of this plus this. She's asking him, do you want the answer in normal math or do you want to get formal math 378 page answer in formal math? Right? So there is a big problem. You should try to teach formal math at the primary level. But from middle school you start that. You start with talking about geometry, about points, and you talk grade and this and that and so on. From middle school onwards, and students don't understand anything. I've already discussed that. At the undergraduate level, you have enormous difficulties with calculus. The IIT JEE entrance must have slogged over calculus, did you not? And I can say with confidence that you probably don't understand a single concept of calculus. If you like, I can administer the test right now. Should I? What's the derivative of e raised to x? What is e raised to x? What is derivative? First answer comes very quickly. Second answer doesn't come. I'm asking a simple question. You know what the derivative of e raised to x is. You don't know what e raised to x is. What details? You just mugged it up. You cannot know. They don't teach you. Fat calculus texts don't teach you what e raised to x is. You need to know how to sum an infinite series. You need to know what formal real numbers are. You need to know set theory, formal set theory. Very few people know that. So you do not even define functions, basic functions. If I ask you what is sin x, you are very suspicious. I'm asking a simple question. You're all in IIT. What is sin x? Opposite side by hypotenuse. Guy can't say. It's an infinite series. It's a circular function. Nothing to do with triangles. How do you calculate sin of 92? Try it on your calculator. No triangle there. No way. It's a circular function defined by means of an infinite series. How did you just calculate sin of 92 degrees? No way you can have a right angle triangle with another angle at 90. So you don't do any of this. You don't do the sum of infinite series. You just mug up some formula. So my pre-test on calculus, all the undergraduates, nothing to do with you specifically, not your fault. You were taught wrong. All of them flunked the test, pre-test. They can't answer here the pre-test. I am not just cheating you, I am not just asking you specifically, but nobody is able to do this. After 3 years of 2 years of calculus in school, previous, previous. So here, for example, are you able to read it? So what are numbers? Are you able to read it? So you are taught about real numbers. Teach about real numbers in class. Let's teach it at the postgraduate level. Students are difficult. So write down exact value of root 2. Anybody? Can't define a real number. They say it's a number which is either rational or irrational. Ask what is I? Square root of -1. Is it rational or irrational? So that's simple thing that we try to set in, or set. What's the definition of set? A collection of objects. Then you apply Russell's paradox. So this is a definition of sin x, sin 92. That's what I'm asking. Part of my limit, derivative. Don't know the definition of derivative. Not your fault. Nobody gets it. Or for example, what is derivative? Is tangent to a curve. What's tangent to a curve? Just touches it at one point. And here is the curve. If you draw the tangent at this point, do not touch it at one point. It will intersect the function at infinity many points. They don't define the tangent. So you are left with nothing. Just complete knowledge. You don't know what an integral is. And then if I ask some simple question like this is just a simple trick question. But how about this one? Dx by x. Okay, how about this? Not taught. Elliptic integral. Only taught in my course. So there is not much difference in my course between Sn x and between sin of x. Or for example, cos and so on. Skip that. Take it up in more detail tomorrow. Tomorrow there is a workshop. So Ganit makes math easy. Students can solve much harder problems. So they have conceptual clarity. Define the function e raised to x, define the function sin raised to sin x, and it's so easy that it can be taught in 5 minutes. Hopefully we will be able to run a workshop here in which, at least experimentally, you will take the course and decide for yourself which is better. I am not teaching. Teach, you can decide. Like it or not. So students can solve harder problems like elliptic integral, statistics with errors. Now these are two things which I did with my children first. And they are in conventional terms very successful. One did his PhD from Harvard, the other did it from Carnegie. But they are not covered in any stakes. They are very easy. I taught it at school level. Simple pendulum. What is there? The first experiment is done. So once more, just look at the tutorial sheet, get some idea what it does. For example, here is the definition of e raised to x, which you are not able to do. You see this? Solve the ODE y prime equal to y. And calculate the value of e and define the exponential function. No need for infinite series, no need for limits, no need for real numbers. And here are the elliptic functions. So this is the equation for Jacob. This is the equation for the simple pendulum. This is the Jacobian elliptic function. Okay. And so you can actually compute the time period in such a way that it agrees with what you observe. Root t equal to 2 pi root over L by 3 does not agree. It has been known for 500 years. Getting knowledge which is 500 years. So on. Okay. So So you are trying to be engineer. I don't know, maybe you want to go and market. I don't know, but I imagine that we are learning to be engineers. Learning to be engineers, even if you want to market, you need to know something about calculus, about derivatives, about demand, supply, graph, maybe something about Black-Scholes equations and so on. You need to have practical value. So Ganit enhances practical value because you are able to do harder problems because it is so easy. There is no need. I mean, you can do 1 plus 1 equals to 2. You can't prove it. So there is no metaphysics or formal math that is redundant. But NCERT and so many of our university professors say that we are still mental slaves. We have to do what they do. This is what they say in the text, and we don't have our own mind. We cannot apply it. We have to do whatever it is. Not sympathetic. It affects the future of and this is the main hurdle, indoctrination into superstition. And I must say IIT BHU is an exception, and I must congratulate you for having invited me here to put this forward. Because you are at least thinking about it. You at least opened your mind to think about it. You don't say, oh, this is nonsense. You won't think about it. At least you are thinking about it. I think this is a very good step, first step forward. Think about it critically. If I am wrong, tell me where I am wrong. By all means. No problem. Also results in better science. Newton didn't understand the challenge. Therefore, his physics failed. Made time metaphysical, a long theory. I won't get into it now. I'm just telling you, not only results in the ability to solve harder problems, it results in better science. Alright, so what we should do, why his physics failed, how to be corrected, we'll discuss it in more detail. Leads to a better theory of gravitation. This time I'm giving an overview. So Ganit is both epistemically superior and practically advantageous. Epistemic superiority we saw was science and engineering application. So that's what you should study. Don't go by the property. Learn it. Try for yourself. You don't like reject. You spend so many years of your life learning tricks to integrate. Total waste. That is the feedback I got from a student. Now we have a Brahmas. Why did we waste so much of our life learning this stuff? Okay. So teaching formal math harms our interest and should teach them. Sometimes you see when you keep talking about this, people say, oh, there is beauty in formal. There is aesthetics in formal. Completely false. Okay. This argument was taken up by me long back. Swami the mathematics was responsible for setting up TIFL. For the damage caused by the TIFR mathematics school. Because the rivalry between him and Bhabha. Please read it if you are interested. The point is, this claim that there is beauty in formal math, false. Complete fraud claim. So there was some beauty in Egyptian Neoplatonic mathematics. It was not about deduction. Okay, it was about religious thought, about turning your mind inward, and sought to arouse the soul, literally the meaning of mathematics. But church, formal mathematics is soulless because the church cursed the related notion of soul for its political interest. Please take a look at my book, 11 Pieces of Time, The Curse of Cyclic Time, chapter 2. It is available in pirated form. This is being recorded. So, church said formal mathematics is about persuasion. We are only interested in persuasion. We are not interested in calculation. We want to persuade we want to persuade Muslims to convert. We want to reason with them. And therefore, that's what formal. Look at what Plato said. Plato said in his Republic, we are a republic, just approaching Republic Day. So, in his Republic, which is supposed to be an ideal state, he said to teach both mathematics and music to the young men of the Republic. Alright? What is the situation today? You don't have to teach people to love music. They are all the time listening to music. Children, are they not? Don't you spend a lot of your time listening to music? Did anybody teach you about music? Don't need to be taught. You appreciate the beauty in it on your own. But what happens with math? Those same millions who find beauty in music only find ugliness in formal math, they run away. They say, "Arey, if you can do this math, get into IIT, you are a genius." Rest of the people are gone. Right? So they hate math, they drop out of math because they find it ugly. And what do you say? You reject the honest opinion of those children who love something happened to math. Something very damaging happened to math between Plato and the church and what is there today. That is why there is this change. And today you say, "Oh, there's this expert says he finds beauty." Why should you believe that expert? His livelihood depends on it. It's not credible. This opinion of children who are completely unbiased, millions of them, and a handful of experts. So it's complete fraud. There's beauty of this sort, beauty of that sort, and I don't want to take names, so I will just proceed. But if beauty is the object of teaching formal math, get your grants to Department of Culture. That is the argument I made. Don't teach it to engineering students unless you have a special course on aesthetics. Okay, treat it as a cultural activity. Teaching it for practical, have your objectives clear. If you are teaching it for practical value, teach practical value. If you claim that there is beauty, I don't say teach it like some Western music somebody wants to learn. So again, the conclusion is that formal math has beauty is a complete fraud. It is like church metaphysics, ugly. You can say anything you like about it because nobody understands. Right? But what is the advantage? Why does the West do it? Because it has a political advantage. Alright? It's a political advantage. In that respect, formal math is superior to Ganit. Ganit is simple, forward thing for applications to science and engineering. It doesn't get into politics, but this gets into politics. So that's the department. There's political value, but of course that political value is only for the West, not for you. Because who lays down the postulate? Who laid down the postulate for set theory? Who laid down the postulate for formal real numbers? Who laid down the postulates for integers? All done in the West. And they will not allow you to do anything different. Supposing I say that, you are obliged to teach calculus with real numbers. I say do teach calculus with non-Archimedean arithmetic. That is how it was done in India using Brahmagupta Avyak Ganit. Much simpler, far, far simpler. No need for limit. But you can't do it. You don't have the freedom, you are slaves. You can't do it. Whether it delivers practical value, because there is no common sense allowed in this. Then company accepts it. Because you are thinking about it and maybe we will try this. So I will explain more about this and the underlying philosophy of heroism. So this mimicry helps the West, but it harms our interests. It's not only in terms of religious beliefs of Stephen Hawking. Stephen Hawking pushes religious beliefs into science, and now they are quarreling with there are lots of problems that occur. For example, the moment I write down a differential equation of physics, I have a d by dt there. Alright? A partial derivative. Doesn't matter. That means time must be like the real line. They've indoctrinated you into the real line. It's a line. That's what the church wants you to believe. Because all the other religious beliefs are all based on a different concept of time. Now, I would accept that those religious beliefs are false. But on physical grounds, not on metaphysical grounds. You are using formal real numbers only on metaphysical grounds. And you completely damage things, damage religious beliefs, and support some kind of wrong religious beliefs just based on politics. So again, take a look at this. What happens? So formal math enables science to be used for promoting a particularly dirty brand of politics. You thought science and religion are at war. Why do you think the best science colleges are still the church institutions like St. Stephen's College, or Xavier's College, or Loyola College? So you have to think of that. Anyway, here is the thing on Christian propaganda and how things work. Big quarrel going on right now in Boston because of what some people in South Africa did, particularly his co-author T.F. Barrett. So because formal math begins from postulate, it enables this kind of politics to be pushed into other things like Kenneth Arrow's impossibility theorem. Got the Nobel Prize. damages our India. That's why you give a Nobel Prize. So again, see the 11 pictures of time not getting. Now, so the conclusion is that it has a political advantage, but that political advantage can be twisted and used by Western authority. But it only benefits the West. We imitate them. We don't get any benefit. So we teach this story to children in Panchatattva. Very elementary story. Just by imitating others, you don't get any benefit. But we do this all the time. Why don't our professors understand it? You know this story? Monkey, cap seller and the monkey. He goes, all his caps are stolen by monkeys. He says, okay, how to get it back? They are up in the tree. So he throws his cap down. All the monkeys do likewise. He gets it back to the advantage. So let me go finally into this aspect that brought a shell of myths in order to save the story. You have something and so the false history that is created is a shell which allows you to save the story. You jump from one myth to another myth. And these myths clutter the colonized mind which tries to save the story. So you have to tell the real story of math. The real story is that although we imitate the West today, West was very primitive in math and backward in math. Alright? Behind everybody else, thousands of years behind Egyptians, for example. It imported and imitated Indian Ganit for 1,000 years before colonialism. And let's take a look at that very quickly. The most basic math that you do, arithmetic, algebra, trigonometry, calculus, probability, was imported from India by the West. I'm not saying everything necessarily developed here. It was imported for its practical value. So, arithmetic algorithms for commerce, trigonometry and calculus, and navigation and economics, so on. But is this a matter of pride? That's the central question. What are you using today? What are you doing today? So the two things differed. Church understanding of math was as a religious tool, and the idea of Ganit was practical value, and therefore led to an epistemological clash. You understand? So let's give you a quick example. Epistemological clash between Ganit and church math. So you know that Indian methods are called algorithm because of Al-Khwarizmi's book Hisab al-Hind. So Al-Khwarizmi's Latinized name was Algorismus. That's why you call them algorithms. Question is, why did Arabs and Europeans import Indian math? Why not Greek or somebody else? That was the only math available. That was the most efficient math available. So Arabs may have learned something from somewhere. Certainly did not learn math from anywhere. Plenty of historical evidence. Basically, Greek and Roman knowledge of mathematics was inferior. Just tell you stories, Archimedes, this, that. Never check the evidence. They know that you will never check. 200 years you have not checked. Just believe whatever is told. Mass of people, nation of 2 billion, 200 years you can't check, and when it's pointed out it is false, then also you cannot check. Very pathetic, isn't it? It was inferior. And that is why efficient Indian arithmetic repeatedly imported by the West, first from Arabs in Cordoba in the 10th century, then from Florentine merchants, 13th century, and then finally direct from India in the 16th century. In the 16th century, it was introduced in the Jesuit syllabus as practical mathematics. But this answer that you imported it because of efficient arithmetic is not given. Because the moment you give the answer, it is exposed that all this thing about Greek scientific achievement is a total fraud. How could they have any scientific achievement how could they do any science if they did mathematics? I'm sorry, this should be efficient. Misspelled. These days I can't see very clearly. That small screen. Efficient element. So stories of Eratosthenes, Archimedes, etc., all fraud. You'll hear them in Wikipedia, but Wikipedia will never give you the primary evidence, never tell you that the evidence, so-called evidence, comes from 1800 years after the source. And they believe that nothing happened to the text in between. It was just blindly copied because all other races lack creativity. That's what Western historians have said. So anyway, you can take a look at my lectures in University of South Africa, not out of. So it had no fractions. Greek and Roman. Do you know how to write fractions in Roman numerals? Anybody? You can't write. They had only some simple fractions like 1 by 4 and so on. And that is why the Greek and Roman calendar was defective. Even after the Gregorian reform, even after the Julian reform. Julian reform, what did it do? What is the duration of the year? Tell me. 365 point. Two 587. Which year are you talking about? Tropical year. Anyway, it's a complicated fraction. We could not write such a fraction. So they said it's 1 by 4. Calendar went wrong. So even addition and multiplication was a problem. Can you do this problem? I asked it in MIT. Nobody could do it. There's a video of that. Take a look. I'm not just telling you something. The video which shows that. Now when I ask this question, people quickly convert to decimal, multiply and convert back. That you're not allowed to do. Do it the way Romans did.